Okay, side-angle side similarity theorem. In this video, we have a couple of topics to go over. The side-angle side theorem, what it means for an angle to be included versus not included. I'm going to show you some examples of triangles that are similar, some that aren't similar, and talk about some common mistakes. And then I have a couple of websites that I'll post as well, but you'll see the URL at the end. All right, so this is the key definition here. The triangles are similar if two pairs of corresponding, and there's a typo in here. We're missing the word sides. If two pairs of corresponding sides are in the same proportion and the included angles are congruent. So that means we need to talk about what an included angle is. You might have been able to notice by the diagram that it was the angle between two sides. That's kind of an informal definition, but it works really well. I might also define it as the angles that are formed by the two given segments or rays. So here we have side A, side B, and together they form the included angle. Here, if this is side A and this is side B, and then we're looking at this angle over here, it's not included. It's not formed by them. It's not between them. It's formed by side B and then the other side. So here's some examples of triangles that are similar by side angle side. We have this first example here with the blue triangles. These two are similar because 3 and 6 are in the same proportion as 2.5 and 5. They both reduce to 1/2. And they have their included angle are congruent. The 70 degrees is that angle included between those two sides is 70 degrees in both diagrams. Now over here on the right, we're looking at a different situation. And at first you don't see any angles marked, but you have to remember that we have vertical angles. Keep coming back. And then we want to match up the corresponding sides. So if I look at the small triangle, we have a side that's 3 and a side that's 4. So 3 is going to correspond to the smaller side in the other triangle, which is 6. And 4 is going to correspond with the larger side in the other triangle, which is 8. Notice we get this crisscross pattern. I like to call this the bow tie diagram because it looks like a bow tie. And bow ties are cool. So again, these both reduce down to 1/2. And we have the angles between the sides congruent by vertical angles. I don't need to know what it is. Just need to know that they're congruent. And I can say the triangles are congruent or similar by side angle side. Here's another example where we have one triangle embedded in the other, which makes things a little bit tricky. So we have this little triangle here in pink. And we have our larger triangle, which I'm going to outline in orange. In the smaller triangle, we have a side length of 2 and a side length of 4. In the larger triangle, we have a side length of 10. So that one on the same side as the 4, and a side length of 5. And 2 over 5 doesn't reduce any farther, but 4 over 10 also is equivalent to 2 over 5. So then what about the angle? Well, they share an angle up at the top, so they have the included angle is just congruent to itself in both diagrams. So these two are congruent by side angle side. Here's a couple that aren't. Sorry, I might have said congruent before. Those two triangles were similar by side angle side. These two triangles could not be considered side angle side because the angle that's marked is the non-included. The non-included angle. So that's a no-go. We don't have a theorem with a non-included angle. This one, they share the angle up at the top, so T is congruent to itself. So then we have our small triangle. I'll do that one in green. And we have 54 and 84. Then we're looking at the larger triangle, which I'll do in blue. And this altogether is 96. And this altogether is 63. So when I reduce those fractions, 54 over 63, those are both divisible by 9. That's 6. Sorry. 6 over 7. 84 and 96 are both divisible by 12, and that gives us 7 over 8. So those two are not in the same proportion, therefore the triangles are not similar. They are not proportional. So some common mistakes are not checking for the proportions. If you just notice, like on the last triangle, that you have a side angle side marked, that's not enough. You do need to check the proportions. And then a lot of times I see students making mistakes when they see a diagram where one triangle has an included angle marked and the other triangle has the non-included angle marked. So that would not be enough information to say whether or not they are similar. So you can jot down these websites if you want, but I'm also going to post them and you'll see them as links underneath the video. And then, of course, don't forget to summarize. So some things that you might summarize: a brief summary of the key definition, if there's any memorable facts or examples, and anything you think you'll forget easily, just be brief about it. Summaries should be just a couple of sentences long.